Hi, Bron. Welcome to the session of platform engineering use cases, the self-service wave, and very lucky to have Per and Venkat from Broadcom here presenting on the topic. I know they're big users; they'll share a bit about it. So I'll go off camera and go on mute. If you've got any questions, please type them in the chat and I'll ask them. I'll interrupt Venkat or Per and ask the question for you. Thank you. Take it away, chaps.
All right, sounds good. Thanks, Stuart, and thanks for joining. So, platform engineering is a hot topic today. A lot of people or a lot of conferences that used to focusing on DevOps are now focusing on platform engineering. So we will talk about what it is. And my name is Per Kroll. I head up a few hundred developers developing products for AOps, DevOps, platform engineering, and so on. And we will talk about how we use platform engineering internally within Broadcom, but also talk about how some of our customers are using platform engineering so you get a feel for that. But before we go too far, Venkat, what are you doing?
Thanks, Per. Hello, everyone. Venkat Balabhadrapatrani. I'm a distinguished engineer. Part of the CTO team is in the Broadcom mainframe software division, and I'm responsible for the architecture of our DevOps and app modernization product portfolio. Over to you, Per.
All right, so let's first define what platform engineering is and maybe talk to the problem. We did a survey working with Forrester, and we surveyed 800 developers, I think, on the mainframe. And there were some very interesting facts coming out of that. The first one is the developers on the mainframe spend only on average 16% of their time coding, but they spend 17% time on building environments and tooling. And that's kind of like a shocker, right? More time spent on setting up environments and the tooling infrastructure than actually coding. Now, it may not be true for you, but it is a high percent for pretty much everybody. And what platform engineering is doing is to provide a set of self-service capabilities that reduces the toil, the amount of time developers, testers, and potentially other people in your organization spend on designing, building, and operating tool chains. Now, platform engineering is broad. So if we go to the next slide, you see that it really is a journey, right? If you spend like 17% according to this survey, there are a lot of different entry points where you can start. And you can incrementally reduce the amount of time your developers and testers spend on setting up that environment. So here we have a few different starting points where you can start with, for example, reducing the effort with setting up DevTools environment. You can do that we will talk about cloud-based development environment, for example. You can get self-service capabilities to set up your test infrastructure. One of the areas we did investment in included CI/CD pipelines, making sure we have centralized CI/CD pipelines and make it easy for anybody to use those standardized central CI/CD pipelines. We internally also did a lot of investment to make it as easy as possible for a developer to do code scanning of different types to ensure that we're delivering code of that are compliant and as secure as ever possible. Other starting point could be to create an easy access from your IDP, which stands for the Internal Development Platform, to accessing the APIs and learning about the APIs you can use to accelerate development. So those are 5 different starting points. The point is that you can start anywhere. What is the problem you're trying to solve? Where is the biggest value of doing investment? Create self-service capabilities in that area, and then move to the next area, and so on. So it will be a journey. Now we go to the next slide. Platform engineering, it is very popular, big topic for organizations doing development and distributed. And a key point we would like to make is that platform engineering carries exactly the same benefits for us on the mainframe as it carries on distributed. Actually, it's even bigger value for us on the mainframe. So on distributed, one of the key values people see is that it removes dependencies on other organizations. But on distributed, if I'm a developer, I want to set up my own environment, my own test environment, for example, I can in most companies do that pretty easily and get an instance, maybe a containerized environment, and I have the rights to do changes to that environment. It may take me time, but I'm not necessarily completely blocked. For most organizations, if I want to request a separate test environment that doesn't exist today, I need to issue a ticket. And I hope that a SysProg group are taking a look at that ticket. And often it takes weeks, sometimes even months, before I get that specialized test environment. And we talk about in our organization, any developer can spin up an LPAR Sysplex in 10 to 20 minutes. And we talk more about that later on. So this is an example of removing those dependencies on other organizations to unblock you as a developer or tester. That value is even bigger for us mainframers than for people on the distributed. Another benefit people see is that it really reduces the time we spend on setting up these tool chains, test environments, and so on. So we can focus more of our time on actually doing coding, actually doing testing. And the other thing is because you have a centralized, managed developer supply chain, dev tool chain, it's more secure. I think we all read about attacks on the software supply chain. You insert some malicious code, and that creates a problem for the downstream application you're producing. So a great way of helping to reduce the number of attack vectors is to centrally manage that software tool chain. So you can centrally do patching of your CI/CD pipeline and so on. And you don't have these many different instances that is very hard to control, where the people have done with the patching and by that reducing the number of attack vectors. This also gives you a standardized tool chain. So when you are moving from one team to another, it's easier for you. You know how things work. It's the same self-service platform. And what we want to do, or what we've done internally, what we recommend you doing, is to use the same platform engineering effort, the same IDP for distributed and mainframe. And that's what we're doing within Broadcom. So of the hundreds of developers I manage, about 70% are doing development on COS, 30% doing development on distributed, but we have only one platform engineering effort, and we think about development, the best practices, as much as possible. The tool chain, where possible, should be the same regardless of the platform. Obviously, you need specialized tool for many things, but the overriding thinking about how you develop software and how you manage tool chain should be the same no matter of the platform. So let's go to the next slide, and I think over to you, Venkat.
Sorry, Per, can I just yes. Ask a question on that last point?
Yeah.
So there's been discussion in the past around bring your own platform for developers, and you said that you're providing this standardized platform for both host and off-host developers. How is that from a culture perspective? That's, it's a really interesting kind of approach. I just wondered if you could elaborate a little bit.
So I'm not sure if I understood the question. Can I?
Sure. So in some organizations, there's a concept of where developers are, want to bring their own tools or services, so it's harder to manage, but the developer has the choice of their tools. And I'm just wondering, how you're providing that platform for both distributed and mainframe developers, how you if you could elaborate a little bit on how you
Yeah.
chose what you did.
Yeah, so you may, for example, say that certain areas a developer chooses their own IDE, as an example. We don't mandate a certain IDE or whatever part of the environment. And then you can provide audited services around it. You still provide a CI/CD pipeline, the ability to set up a test environment, develop an environment, the security scanning tools, and so on. Those are provided with a platform, but you may choose certain areas where you are leaving up to the developer to bring their own, for example, IDE of choice to that environment. That is one option. The other one is to make sure you're building out, if a developer can choose between 2, 3, 4 different options, you can self-service each of those different options and give you flexibility. So both of those scenarios can be accommodated based on what you're trying to achieve. Venkat, anything you would add to that?
I think that's the core of it, right? It comes down to the evaluating what are the entry points that you want to start with, and figuring out what are the aspects that you want to standardize to the extent possible and provide that environment as a common starting point. And where there are, organizations where providing the flexibility, let developers choose, and basically also pay attention to the fact that as they are leveraging those tools, are there things that they're doing repeatedly, and can that be a candidate for automation, right? I think that's the thought process, and in terms of how you would evolve. And I think, Per mentioned it's a journey, right?
Right.
And we know that culture change is a journey as well. So that's the way we evolved, and that's how we're seeing organizations who are on the journey evolving as well.
Beautiful. So there is still that element of self-service and evolution on the platform. I guess that's got to be healthy for everyone. Thank you.
Yeah, and I give you a concrete example on how we're thinking internally, right? I mean, we obviously want all of our developers to use as modern, as productive tools as possible. But we have a number of people that are very comfortable and grew up or been using VS Code and Git. And that's their natural environment. Others, they are 35 years into using ISPF and directly interacting with Endeavor. And it is not productive for me as a engineering leader to, on day one, force everybody to change how they're developing software. So that's an example where I want to give developers the freedom. I encourage, and many are using VS Code or IntelliJ if they're doing Java development. But then if you are much more productive with ISPF, we can allow that also, right? So that's an example where we make an explicit choice. Now, down the road, maybe we kind of like encourage more and more people to move towards VS Code and IntelliJ, but we for sure want to make it easy to use those environments in the hope as many as possible adopt it without necessarily forcing a specific environment in every instance. But when it comes to security and testing, we are much harder on, here's the standard, you need to do these type of code scannings. That is kind of like more of a mandate, right? But in other areas, we give flexibility. So platform engineering doesn't prevent you from choosing where you want to standardize versus where you want to give that flexibility. So excellent question.
No, and just to add to what Per said, for that specific example, right? The journey that we are on internally is for the folks and developers who want to use Git and VS Code or IntelliJ platforms, there is an amount of setup that they need to go through. Whereas if you're on ISPF, we know that environment is already set up. I just need to log in and away I go, right? So the focus in terms of how we want to help our developers is we are trying to automate the setup of those VS Code, Git, and IntelliJ environments so that the folks who are interested in it are not spending as much time in setting up the environments and the dependencies, but can just go run with it. Whereas the same kind of thing won't be applicable for, like, say, an ISPF. So that's a case where we are providing the flexibility as well as trying to address the pain point that the different platforms might bring. So with that, I think it's perfect segue into the next slide, which is mainframe and platform engineering, which is the core message here is with the focus is on self-service, the focus is on standardized developer tool chain, the focus is having that API first mindset, because anything and everything that we're talking about here is about automation. And organizations have been on the journey of automating their workflows. They've been on the journey of creating those APIs. It is now just about taking those automations and orchestrating things in a way that it actually helps developers focus on the things that they need to do. And it is not about creating something specific to mainframe, but as we just talked about the examples, figuring out what are the key pain points, what are the areas where we can optimize and helping the developers focus and automate some of those things. Now, as part of this conversation, we are talking a lot about developer self-service and making the life of a developer easier. But I want to go back to the slide where we talked about the value of platform engineering. And there was a row where mainframe had 3 check boxes. And as Per said, the value for mainframe is a lot more than a developer, because we all know that the system administrators, the database administrators, the CICS admins, they are scarce resources. And anything and everything that we can do to help the developers be more self-sufficient equates to having those admins more time to focus on the things that they need to do. And that is the core concept from a platform engineering, and how it brings additional value to mainframe. But the key again is do not carve or do something that is specific to mainframe. Just there are ways and techniques and approaches that enable organizations to plug into their platform engineering efforts. And I can assure you, as we are talking to customers, a lot of the organizations are already doing things. They're just not calling it platform engineering. And we were in the same boat, right? Because we started this journey 4 years ago. And the word platform engineering didn't even exist at that time, right? So the key is just tapping into that standardization, understanding what is happening across the organization, and leveraging the power of APIs and automation to integrate the mainframe related self-service capabilities into that existing platform engineering effort, I think is the key message for it. Now, so we talked about what is platform engineering. We talked about enabling developers and automation and providing self-service capabilities. What we're going to do now is dive into a very specific example. And we already kind of started touching on that as part of the question that Stuart, you asked, is in terms of what are the things that developers are needing, right? So this very specific example that we are going to look at is the journey of a developer who is intending or wanting to use a modern development environment to do their mainframe application development and maintenance. So the as-is scenario, like today, a developer would come in, let's say they pick VS Code, right? So they need to install VS Code on their machine, and then go to the VS Code marketplace within VS Code and say, what are the extensions that are available to me to do my job? They may or may not know that information, right? Because of the ecosystem that exists out there. So they need to search and install. And then they say, okay, now that I have the extensions that I think are needed for my job, I need to connect to a mainframe. How do I configure my connection to the mainframe? What is the port number that I need to use? What is the protocol we are using? All of that information is not available to them readily, right? And then the connection to external tools like Jenkins, Git repositories, enterprise Git repositories like GitHub, GitLab, Bitbucket, Azure DevOps, you name it, that organizations are using, they need to be able to do that as well. And then what is my build engine? Do I need a separate build tool? What is my debug environment? What if I'm doing a COBOL Java application? What are the pieces that I need? So these are all the questions that a developer is going through as they're setting up the environment. So any question that they're asking or any place where they're depending on a different persona is an additional cognitive load that they have to work through. So this is the current as-is environment today. And the to be would be is to say a developer through a command line interface or a portal clicks a button, executes a command, and there are a set of workflows that will go through the process of setting up the development environment with all the dependencies needed so that the developer can just jump in and focus on the thing that they need to do. So that is a very concrete example of self-service that will eliminate the steps that a user would have to, or a developer would have to go through to set up their modern development environment. And we're going to go through a demo of setting up such an environment with these workflows. So the key concepts here are, as I mentioned, organizations have been on the journey of creating automation. So the pieces exist. The workflows are, think of it as a way to orchestrate those different pieces of automation to accomplish a much bigger task. That's exactly what we're talking about here, conceptually. So with that, let's focus on what are the key value points here, right? And as I mentioned, the thing is the developer will have a pre-configured development environment ready to go. And this is relevant and more important for organizations in the mainframe realm because most of the organizations are on this modernization journey. So there is already a learning curve that teams are going through. And even if for folks who are familiar with VS Code and can navigate the marketplace, figure out the extensions and things like that, the pieces on how it is communicating to the mainframe may not be that visible to them, right? So there are pieces and parts of the story that I was telling that developers can need or can use some help. So the idea here is at the end of that workflow, the developer will have a pre-configured development environment ready to code, automated connections to mainframe, all of the tools. So the idea there is, as you're thinking about platform engineering, you can have templates for each team so that the provisioning can pick the right template and enable those connections and configurations to the mainframe, to other tools that the developers are using, and so that they don't have to worry about it. They don't have to know. They don't have to go tap on someone's shoulder to figure that out. And then last but not least is the self-service, which translates to instant productivity. I'm not waiting on anybody. I'm not opening a ticket. I'm not going, sending a Slack message or walking to someone else's cube to figure out some information to do my job as a developer. So that's the key value that we're going to look at as part of this very specific example. So with that, I'm going to dive, before we go there. So the approach, as I mentioned, API and CLI driven. So that's the crux of the whole infrastructure, right? APIs enable automation, and we are taking an approach where for platform engineering, in order to bring mainframe to the existing platform that organizations are using, we are providing primarily a CLI-driven approach and giving organizations the flexibility to plug that into their platform/internal developer platform, which is IDP, but not prereq or prescribe something. So that's the core part of it. And then workflows as code. So we talked about the workflows, and we are leveraging an open source tool called Conductor for orchestrating these workflows. And again, the goal is to enable organizations leverage the existing platform. And we're providing, for this specific use case and beyond, workflows that can work with Docker, Podman, Kubernetes. And you may be wondering why. Well, the reality is there are different container runtimes that are available out there. And different container runtime environments have their own pros and cons in terms of the setup that is needed, And it really comes down to what that particular organization wants. So we are providing out of the box workflows that enable organizations to run these in Docker, Podman, or the ultra enterprise ready environments like Kubernetes. And if somebody wants to leverage cloud development environments like Strong Network or OpenShift Dev Spaces or GitHub Copilot, you can leverage these workflows for those environments as well. So again, the key here is the flexibility and providing organizations a way to scale from a POC to a small deployment to an enterprise deployment in a systematic fashion, rather than having heavy prereqs on the technology that is needed to be able to set this up. So that's the core idea. Again, the message here is it is possible to have the workflows be configured to different runtimes and provide organizations the flexibility rather than enforcing a certain set of prereqs. So with that as the base, I'll pause here for a minute before jumping into the demo. Any questions so far, Stuart, that are in the chat or that you may have?
No, there's nothing in the chat at the moment. Thank you, Venkat.
Perfect. Okay, so with that, I'll jump into the demo. So this is a recorded demo. There is audio. So if you're listening to this, I would suggest you bump up the volume on your laptops and go through it.
On the right
Sorry.
hand side, I have a Red Hat machine, essentially has got Podman installed with the APIs, and I've already uploaded the VS Code container image. So that's the image that during setup and configuration you will use, so that when developers are provisioning the environment, it'll create an instance from this particular image. We also want to make sure there's nothing running right now. There's no containers running. So with that, we'll go and talk about the experience here. So the experience first one is that I'm just calling Orchestrator, and it's the command line that gives me a set of options, just like any other command line, whether you're using kube control, Git, or so on. It's very similar. It's based on common command line technology. And here, when I go say, give me all the definitions. So I said, give me definitions will give me all the self-service workflows that potentially I can execute as a developer. So it went to the backend server, and it's giving you back each workflow, a workflow name, a version of that workflow, so that developers can invoke that workflow with a prescribed input. And that's basically it. That's the experience. So with that, we're going to first create the one with Podman. So what does it look like? So I said, Orchestrator, execute the workflow. The definition is provision VS Code environment in Podman. The input is Podman JSON. So what is that?
So just to kind of recap here, what we have done so far is in the from the command line, right? We have a set of workflows to create a self-provision an IDE, like a VS Code IDE. And there are different workflows targeting different runtimes, as we talked about earlier, Docker, Podman. And what you saw so far is the ability to list all the workflows and then leveraging that command line to initiate a workflow so that it can start the process of provisioning. And what it is leveraging under the covers is the VS Code server, which is available for everybody, and packaging it as a Docker image that can be executed in any runtime.
What does the input look like? So if you look at this one, this is what we are executing. That's the command line we're executing. That's the input. The input essentially is saying, what is the container host name? So that's the Red Hat machine that I am currently running, where I have the IP, the fully qualified name of the machine, and then I have the API for the Podman that is being enabled so that I can use the Podman API to orchestrate. So remember, I was talking about APIs. So these are all the standard APIs that are available for different container runtimes. So this is Docker, this is Podman, this is Kubernetes, and we're just leveraging those APIs to provision. And then the image is the container image ID. You saw me show you that the image got uploaded. That's the image ID, so that the orchestration knows which image to use to provision the instance. The user ID is just a unique label for that container associated with the user so that we don't create duplicates. And that's pretty much it. So we're going to go run that. And what you should see is things happening very quickly. You're getting live feedback on the progress of the workflow. It's going and verifying that an image exists, the container does not exist. Let me create one, and it's done. It's essentially created this. Now, if I go look at PS, my container is running. So the one it's running at 34573 port, that's the port here. And it's dynamically allocating port management on that virtual machine. You don't need to associate any ports. And that's pretty much it. That's the developer experience. So you could see how we completely abstracted this part. So let's go here. We're going to go and launch it and launch it in a browser. So I said it's a URL. It's essentially going to launch the browser where you're bringing up VS Code environment. It takes a little bit of time initially as it's initializing the VS Code server and all its extensions are coming up. While that's going on, you'll notice that similarly for Docker, you'll have a Docker example here. But in this case, one slight variation is that for Docker, we are also doing mounted volumes. So mounted volumes is a concept in containers where if you want the data to not exist in the container, you can mount the data from outside the container. So this way you can upgrade containers and your data is still preserved. Depending on your environments, you may choose to use mounted paths or you may not. In our case with Podman, our data is within the container because we're doing a training workshop or a simple training in the data. The data doesn't get deleted until you delete the container. Starting and stopping the container does not delete the data. But in case you want to preserve your data in a cloud bucket, you can use mounted paths. And the difference is in the input, you're giving a host directory path and then a container directory path so that it mounts the user directory to the container directory so that the user's data is preserved outside. So that would be typically pointing to a cloud bucket kind of a thing. Going back here, our browser is up and running. Our VS Code extensions are all up and running. As you can see, we can go look at the terminal. I'm going to open up a terminal window here. Go back here. And the key part here to notice that all the extensions that we want, Code4Z, Test4Z, HBJS, all of them have been created. We also loaded up some sample COBOL project. We can go load that up kind of a thing. I'm going to go source control here, open the folder. It's the Biz app. So it's essentially Biz app is just a sample COBOL application that we created, and it's based off on the Gen app application from IBM. So here I'm trying to load up some COBOL source code, and because of the extensions being there, the COBOL language support, and all the syntax highlighting and so on. So essentially that's your full VS Code experience, quickly able to, and you can run, as an example, you can also, we bundled in this example to showcase, we also bundled team build binaries. So you can have code changes that get synchronized. It's already part of the container. So it'll be like ./syncz.
So just to recap again, I think what you have seen here is a developer executing a command that resulted in the creation of a VS Code environment that is configured with all the extensions. And in our case, we used the Code4Z extensions and populated the workspace with a sample application. So the magic of pulling in the extensions, downloading them, and the configuration of the sample application and any connections, though that is being handled by the workflows that are being created. So if you're thinking about how can I, as an organization, get to this point, well, there are two primary roles. One is an admin who is creating these workflows to meet the needs of a developer. What is that they want, and ensuring that the workflows and the templates are available to do the right thing. And once those workflows are made available by the admin/platform engineering team, the end user is either running a command or clicking a button in a web browser to execute the actions. And that's essentially the user experience and the self-service capability that we've been talking about. And as you can see in this environment, the developer is not worried about what extensions do I need. And the terminal that you just saw in the demo is the build infrastructure. So the build piece, in our case, is the team build that we showed as part of the demo, is an additional tool. And we package that into the same Docker container so that from a developer's perspective, they're not worried about bringing in additional tools, but rather have everything be part of the container. They just execute it, everything is set up, and then they can focus on doing their job, which is editing. So if you're thinking about, Per's comment about developers spending only 16% of time coding and 17% on the environment setup, even if you take that 17% of time that they're taking to set up the development environment to 7 or 10%, that is still a significant gain in productivity. And that's exactly what platform engineering will put you on the path of. And with that, I think, Per, I hand it over to you.
Sounds good. So last year I had the opportunity to do a keynote at a conference with Vamsi Bulgaredi from Legal & General, great guy. And I was really fascinated by his story. He talked about how they started with asking developers what they like and what they don't like in their current work environment. And a lot of the comments was around how developers felt they were wasting time on, for example, setting up environments. So they did investments in platform engineering. The benefit when you do that investment is both, obviously, as we talked about, you reduce the amount of time developers and testers need to spend on setting up the environment, but you also get faster adoption of a modern developer tool chain, which gives you yet more productivity improvement with that modern tool chain. So they more than triple productivity. They can now do changes like a bug fix or similar and get that to pre-production in hours, took much longer time before. And maybe the most important change is that they did surveys of developer happiness before and after. And developers were much more happy after this transformation, after these changes. And happy developers are productive developers. So they got recognized and did a lot of presentation at non-mainframe customer conferences. And it's great to see a mainframe team presenting to non-mainframer on the art of possible around how to drive effective tool change and platform engineering efforts. So big shout out to Vamsi and his team. On the next slide, going to our internal adoption. So we started probably, I think it was around 3 years ago. And at that time, we looked at one of the open source platforms, which is Backstage. It wasn't quite mature enough, so we decided to build our own. Today, we would probably chosen Tanzu or Backstage or whatever. There are platforms from Red Hat. There are a lot of them out there, right? But we built our own. And what you see here is that you can get information about cloud costs. You can get the code scanning tools, test tools. You can get all kinds of different self-service capabilities from this platform. If you go to the next slide, looking at some of the benefits we have got, we're using a virtual environment as much as we can. So we use ZVDT, so that is the emulated ZOS environment for the Z hardware. And that allows you to spin up an LPAR in 10 minutes. For Sysplexes, it doesn't yet support. We need to use ZDNT, which runs on x86, is running on our Google Cloud. And you can spin up a Sysplex in 20 minutes. So any developer can spin up as many developer and test environments they need in literally minutes. Now, we've also done it very easy to invest in test automation. It's never easy because there's a lot of work to do that, but that's been critical for our agile journey. So we moved in the last few years. So every core product have about 80% test automation, and allows us to do releases much more frequently and do development much more rapidly because we can directly find problems if you introduce that in development. I mentioned that we standardized on CI/CD pipelines. That was an area where people had concern, oh, I've been driving so much innovation in my specialized Jenkins pipeline. I actually don't want our developers to spend time innovating on the Jenkins pipeline. That's a standard thing. I want them to innovate to drive more value to our customers, right? You want to spend that time on innovating how you write the code. So that also drives better security. And because we have standardized order scanning tools, we know exactly what has been produced and so on. We can in a minute say if there is new exposure, like a log4j type of exposure, we can within a minute say exactly which applications could be impacted. So we can directly reach out to the 17 teams that needs to look at this and tell us whether they really are impacted and tell us when they can do a fix if that is warranted. Before, there was a lot of emails, could take days. Go to the last slide, I think. And so in summary, we see a lot of value in self-service, reducing toil, making developers happier. We also see that security in governments, you have role-based controls, so there's no, you ensure that it's secure. There are proven approaches for that, but it's actually more secure because you have a centrally managed environment that can be protected more easily. And remember, if you're going down this, you will not, you can start in many places and you go down a journey. Your journey will be different based on what your needs are. We're super happy to work with you, sharing anything we've done, help you on that journey. So just reach out to me or Venkat. We're happy to go into deeper discussion and do demonstration of things we've done or tell you more about customers and what we've done internally. With that, going to the next slide, I hope this was of value. We will love your feedback. So please submit that and let us know how can we change this for future presentations or future conferences so it addresses specifically the things you maybe have questions around. But again, reach out if you have any questions. Venkat, anything else to add?
No, thank you. I think you covered it well.
Excellent. And back to you, Stuart.
Thank you very much. Whenever I see this, it always just seems so normal, you know, to the kind of problems that you're solving have been around for a long time. And as you pointed out with DevOps, we on the mainframe have been doing DevOps for a while. We just didn't call it that. And I think there is some platform engineering. We just haven't called it that. But solving some of those things that I've written user guides for to connect, you know, to what port and how to do this and, you know, screenshots and keeping it updated. All of a sudden, you're automating all of that manual effort in providing the best developer platform that anyone could want. So I'm not sure that you're going to productize what you've done or whatever, but I know there are products out there. I may well work for a company that's doing some of this work, but it makes a lot of sense. So thank you very much for the detail, and I'm sure this video will get views in the next 12 to 18 months, and I look forward to seeing, you know, the advancements when we meet together in November. So thank you for everything, and that's it for today in the AppDev stream at GS UK Virtual. So thanks everyone. Bye for now, Venkat and Per. Thank you very much.
Bye.
Take care.